Ses. Herkese merhaba, hoş geldiniz öncelikle. Bugün Dünyanın önde gelen yangın ekolojisi uzmanlarından Juli Pausas bizle birlikte olacak ve orman yangınlarının özellikle son dönemde birçok ülkenin başına sorun olan mega orman yangınlarının sebeplerini, sonuçlarını ve etkilerinden bahsedecek. Kendisi İspanya Ulusal Araştırma Kurumu, yani İspanya'nın TÜBİTAK'ı aslında, ona bağlı Çölleşti Araştırmaları Merkezi'nde çalışmakta araştırmacı olarak ve yani bu konuda oldukça konusunda lider bir araştırmacı, dünyadaki teorileri şekillendirebilen bir araştırmacı. 100'ün üzerinde yayını, çok sayıda kitabı da var, çok sayıda atıfı olan bir araştırmacı ve burada da İspanya Büyükelçiliği'nin daveti ve desteği üzerine bulunmakta. Özellikle İspanya'nın son Türkiye'nin yaşadığı yangınlarda verdiği desteğe ek olarak işte Büyükelçiliğin de bunun önünde çabaları var. Ve dün Sayın Büyükelçi Javier Argueta ile birlikteydik ve kendisi Türkiye ile İspanya'nın bir yangınla mücadele konusunda anlaşma imzalamak üzere olduğundan bahsetti. Aramızda ayrıca İspanyol Büyükelçiliği Müsteşarı Sayın Antonio Doblas da burada. Kendisine de teşekkür ediyoruz. Geldiği, katıldığı için, desteği için. Juli'ye vermeden sözü tekrar onun burada olmasını ve buradaki çalışmalarına destek olan kurumlara da teşekkür etmek istiyorum. Tekrar başta İspanyol Büyükelçiliği olmak üzere. Ayrıca Hacettepe Üniversitesi'ne ev sahipliği için teşekkür ediyorum. Ve de kendisiyle birkaç gün boyunca güneyde yanmış alanlarda seyahatimiz ve arazi çalışmalarımız olacak. Bunu da finanse eden Çevre Şehircilik ve İklim Değişikliği Bakanlığı'na da ayrıca teşekkür ediyoruz. Ben son olarak sözü Juli'ye bırakmadan önce özellikle öğrenci arkadaşlarımıza hani sunum İngilizce olacak, eğer hani bu konuda soru sormak konusunda çekinceleriniz olursa dil bariyerini aşmak adına ben en sonunda yardımcı olacağımı söyleyeyim. Hani eğer Türkçe sorarsanız ben memnuniyetle İngilizceyi çevirebilirim ya da tam tersi. O konuda da lütfen rahat olabilirsiniz. Ben kendisini kürsüye davet ediyorum. Juli, please.
Okay, good morning everybody. Thank you very much, Secretary, for your introduction. I don't know what did you say, but probably you were very kind with me. So, can you hear well? Okay. So, first of all, thank you very much to the university for inviting me here, and special thanks to the Spanish Embassy here in Ankara.
Your microphone is not open.
It's not open?
Open.
Yeah, maybe it's not. Can you hear well? Is it okay now? Now? Yeah? Okay. So, I would say that thank you very much for the university for organizing this, and special thanks to the Spanish Embassy here in Ankara, which financed this talk. So, what I'm going to talk today is a bit things that we have learned in Spain from all these fires that are occurring in the last few years. And what I'm trying to do is to give a basic introduction to the ecology of these systems, because for us, understanding the ecology of these systems helps us to manage these problems. So we believe that this basic science is an important contribution to understand the fire problem. So I will start saying that what's the Mediterranean climate. So we all know more or less what is the Mediterranean climate, and it's very interesting because it's areas with shrublands, evergreen forests, semi-deciduous forests, coniferous forests, and both Spain and Turkey have, they are at similar latitude, and they share more or less a similar environment. They share a similar vegetation, and also they share a lot of problems. So that's why it's interesting that we can each other learn from the other one, because we share a lot of things. So the Mediterranean climate it's a very old climate. It appears here in about between 3 and 5 millions of years ago, and the characteristics of this climate is that we have dense vegetation in general. Cover is quite high, and it has these warm and dry summers, which is very typical of the Mediterranean climate, and we have dry storms. And these components, it means that in Mediterranean climate we always have fuel, so we have vegetation that can burn. We usually have continuous vegetation that can burn. We have climatic conditions that are ideal for fire spread, and we have these light storms that produce these emissions. And in sometimes we can have thousands of emissions in the middle of summer. So this means that fire is a very old and natural process in these ecosystems. It's not something that is human-made only. It's already a natural factor. And yet, these Mediterranean ecosystems are hotspots of biodiversity. So we've been few millions of years with frequent fires, and we still are a hotspot of biodiversity. So this means that many of these species are some way adapted to these frequent fires. So what's this adaptation? So how plants survive and regenerate after fire or after these recurrent fires? So what traits, what strategies has the plants to survive and persist generation after generation when we have these fire-prone ecosystems? Ecosystems that are very prone to fire, that fire is very easy to start and to spread. And then we'll go through some of them, the main ones. And the main characteristics, we call the traits, the main characteristics of the plants. The first one is resprout. Many of our Mediterranean species, they can resprout after fire, even like this species, 15 days after a fire. And this is a very intense fire because, as you can see, most of the vegetation was consumed, and even this, with a very high intensity fire, many plants can sprout from the base. So the way that the plants sprout depends on the intensity of the fire severity. So many of these plants have these buds, and if they don't get burned, they sprout from the base. But if they get all burned, they have buds in the base, and because the soil is very good protection of the heat, you very often have these buds that you sprout. So that's why you find these sprouting from below ground. So this is a very typical in many Mediterranean plants. But there is, I'm not going to go in detail, but there is plenty of ways that the plants can sprout. One typical structure is this lignum tubers. Many plants have these bulbs, these lignum tubers that are below ground. So, and there is plenty of buds there. If you unearth them, you can see them. Otherwise, you don't see them. Or some plants they have these bulbs or tubers and rhizomes and so on. So there is a diversity of structures, usually below ground structures that are protected from the fire, and the plants use them for sprouting after fire. The other trait that is very important in some Mediterranean ecosystems is to have a thick bark. Some plants, typically is the cork oak that you don't have here, but in Spain it's quite frequent. But there are many pines that when they have these, what we call these surface fires, these low intensity fires, because these trees, these pines have thick bark, they can survive. So the fire goes through the story, but the trees don't die. And this is an example of a picture that I took a few years ago when my first time here in Marmaris. And this is a Pinus Borgia. And if you see, this is a tool to measure the bark thickness. And this has 5 centimeters. No? And we push them, and this means that this bark is more than 5 centimeters in thick, more than that. So this means that these pines and this Pinus Borgia can support some of these fires as well. No? Not all Pinus Borgia have this thick bark, but many populations have this thick bark. So and can survive this kind of fires. The third trait that I like to mention is that some plants have this seed bank in the soil, and then they germinate very well. So some plants, like this one, the mother plant, dies after fire. They don't sprout. They don't have these buds for sprouting. But in the offspring, the descendants, they regenerate very well. These plants, most of the plants, every year they generate flowers and they generate seeds, and then they disperse. And many seeds in spring they germinate. But these many Mediterranean plants, the seeds of every year are in the soil. They remain in the soil dormant, and when there is a fire, then boom, all of them germinate. It's a strategy that's very different from the sprouting. So the mother dies, but you have all these descendants germinating after fire. And it's very interesting because how we understand it, how we study this. We get seeds of these plants and we put in control conditions to germinate, and we put the germination, the seeds in heat, in high heat, in heat simulating a fire. No? And we see that the germination in conditions of 100 degrees, which is something that it can, temperatures that reach the soil during a fire, then the germination is much higher. No? And here is a couple of examples of Devum and Ulex and Cistus. No? They germinate much more in fire, after fire, than when there is no fire. Because of the heat shock, no? This heat. And there are other plants that instead of germinating after the heat shock, they germinate because of the smoke. No? So some plants, they don't germinate if you do anything, they don't germinate if you heat them, but the smoke of the fires stimulate the germination. No? So some plants do that, some Labiate, for example, do that. So we have some plants that they germinate very well, they take the opportunity after fire to germinate and to leave descendants. And this is another way to generate a seed bank for some plants. And this is the case of the pines as well. Many pines, and also some Pinus Borgia in Marmaris as well. These pictures are from Marmaris. Most of the pines produce cones every year, and in summer the cones are open and the seeds are dispersed. But these pines that live in fire-prone ecosystems, the cones remain closed. No? So the tree keep growing. So these cones probably have 5 or 6 years old or more, and they are closed. And when there is a fire, the cones open, and then the seeds are dispersed, and then we have this germination that is being demonstrated after these fires of this summer here, and then you get again this population. So this cycle occurs in some of these pines. So we have to understand which populations of these pines have these cones and which populations of these pines have this thick part to understand their natural fire regime. And so this means that these pines can survive very high intensity fires because the canopy gets burned, the cones, they open them and they germinate. So, and this is a natural cycle of these pines. The fourth trait that I was interested in showing you is that fire-stimulated flowering. This is another trait that is not very well known, but some species, usually are herbaceous species, but there is a lot of diversity in this kind of species. after the fire, they flower massively. They have a bloom of flowering, and then they produce seeds, and they regenerate. So there are plants that without fire, they probably produce very little flowers, very few flowers, but after the fire, they bloom. So they take this opportunity of the fires to flower, because after fire there is much more resources. The pollinators can find them very easily, because if there is a dense forest, these flowers don't have the opportunity to get flowered and to get pollinated. So that's another trait that is common in nature and ecosystems, both in high and low intensity fires. And the last trait that I like to show you is flammability. Flammability is a very complex trait. It has lots of problems, but in general we define flammability here for simplicity is the capacity to start and spread a fire. And some plants are very flammable. They have all these thin vegetation, the thin branches, thin leaves, and sometimes even they keep the dead biomass in the plant instead of falling down. They are retained in the plant. So, and then any spark they burn very easily. And these plants that they burn very easily, they have this germination stimulated by fire, what I explained before. These seed banks and so on. And they seed bank in the soil. So they get burned and then they germinate. The descendants germinate the offspring, and then they grow again. So they have all this cycle. And this, for example, for the plant, from the point of view of the plant, is successful, of course. Of course, for the management, it's a problem because this is very flammable, so it generates a lot of fires, and the plant reproduces and keeps generating fire. So it's from the ecological point of view, the plant is very successful, but from the management point of view, is a problem. So we call sometimes these pyrophytes, these plants that have lots of fuel, thin fuel that burns very easily, but they also regenerate very well after fire. And also there is a variability in pines about this flammability. We have some pines, and this is Pinus halepensis that is very common in Spain, and that have all these branches and all these dense vegetation, the dense branches from the bottom to the top, and they have these serotinous cones in the canopy. So they have this branch retention and serotonin, so they have this. They can support these high intensity fires because they die, but the cones open and they reproduce. But then we have other pines that they don't have these serotinous cones, and if they burn all of the pine, they die and they don't reproduce. But they can survive because they have this thick bark and they self-prune the branches so the fire can go through below. So these are two very different strategies for the plants to live in fire environments. And of course this can be used as well to understand and to manage and to move from one place to another, to change the structure and to modify fire spread. So even within genus, within a pines, we can find these contrasting strategies to survive, to persist in different fire regions. High intensity ground fires, you have serotinous cones, and low intensity surface fires, you have thick bark, no branches in the bottom, so the fire, and you can see the black area, because the fires go through. So, therefore, wildfires has been around for long in our Mediterranean ecosystems, and we have these plants that have these structures, the traits that allow them to survive fires. So they are part of our biodiversity. It's like many of our plants have strategies to survive drought. If there is no rainfall, there is drought. The plants have adaptation to survive. many plants also have adaptation to survive fire. And different ecosystems have different climates and different fire regimes. And for example, if we look at temperate ecosystems, Mediterranean, arid, mountain, Atlantic, boreal, etc., we see that we have different characteristics of fire. The fire size changes from one ecosystem to the other, the fire intensity also changes, the fire season, the fire frequency, etc. So, and different plants are adapted to all these characteristics. So the problem is when we go out from the characteristics that the plants are adapted. But we will talk about this a bit later. Well, that's the theory of the basics to understand what happens with in the post-fire regeneration after fire. But then we arrive to what happens this summer here in Turkey, especially in the south. So, and we know that has been a very exceptional year with many fires occurring simultaneously at the same time. And many of these fires were very big, many thousands of hectares burned. So, and this is, of course, is quite exceptional if you look at the statistics this year in red, and the mean in orange is the mean of many years in orange. So it's an exceptional year, and you know better than me, an exceptional year for Turkey, for Greece, for Italy. These three countries, they were suffering these more fires than other years. Well, in Spain and Portugal, it's been okay that year. And again, this is, if you look at the area burned this summer compared with the average, which is much higher. So it's clear that this year has been for you, for Turkey, it's been a very exceptional year. So what's the reason why? What happened? Well, perhaps the simple answer is climatic change. Of course, it's the climatic change. But why it happens this year and not other years and so on? So this is the simple answer. We are going to try to analyze why we have these megafires frequent in the recent years and also in the future. So the idea is explained in this paper is that what we have to understand what we call the fire triangle, the three key processes that drive wildfires: ignitions, fume, and drought. So I will explain each one in a minute. So what happens with ignitions? Usually, the more ignitions you have, the higher is the probability that you have a fire. But this tendency is not a linear process. So there is a threshold from which, when you cross this threshold of the number of ignitions, the probability of having a fire is very high. So there is a threshold, and then it's very easy to have a fire. No? Usually, natural emissions are lightning. And the frequency of lightnings of lightning storms is relatively slow or whatever. No? But of course, what we are doing is that we are living in many areas. We are living between the forest, within the forest environment, and this creates sparks because of the combustion of the engines, because of the cigarettes, because of anything, tools and so on. So we are increasing the number of ignitions from the natural conditions. So more often we cross this threshold. So we tend to cross this threshold more often than before. The other component is the fuel, the continuity of the fuel. The more continuous is the fuel, the higher is the probability of fire spread. But again, this is not linear. There is a threshold as well. There is a threshold of fuel continuity. When we cross this threshold, the fire spread very quickly and very easily. And for example, rural abandonment is one of the processes that increase discontinuity. It's in many Mediterranean ecosystems, the rural abandonment makes the landscapes much more homogeneous and increase the continuity of the field, and then we cross this threshold very quick. But not only rural abandonment, many of the tree plantations, if they are not well preserved, if they are not well managed, then it's easy to increase the field continuity. Again, invasive species as well. Even the increase of CO2 increase the vegetation, and then it's much very easy again to increase the field continuity. And even the fire suppression, which is counterintuitive, but if you have a lot of fire suppression, then you have a much more vegetation, and then you can increase the continuity. So that's the second point. And the third point is drought. Again, drought, the more flammable is the ecosystem. And again, it's not linear, there is as well a threshold. And we know this very well. If you look at dry years and wet years and the area burned, in the dry years, the burn is much higher than in the wet years. No? And of course, climatic change is moving this towards this end. So we are crossing the threshold much often than before. So when we cross the three thresholds, and then is when we have this megafires. We cross the emission threshold, we cross the fuel continuity threshold, and we cross the drought threshold. And then is when we have these massive fires everywhere. But this is even more complicated because in the weather, the fire, what we call the fire weather, may reduce these thresholds. So, for example, if there is wind or if there is a heat wave, then the threshold is lower. So when you have a heat wave, or you have wind, or you have both, you need less emissions to have a fire, because the threshold gets lower. Or you need less fuel continuity to spread the fire, or you get less drought to get high flammability. So in conditions like you had in last summer, when you had a lot of heat waves, you have all these three components, and then the thresholds were reduced, and then you cross the thresholds very easily everywhere. And that is what generates this emergency of so many fires. So climatic change is increasing this drought, so it's increasing this drought going towards, and also increasing these heat waves, so moving the thresholds to lower values. And of course the consequences, and this is data for Spain, for example, the consequences of this crossing very frequently these thresholds is that the fire size increased a lot. This is in the past, and this is in the last years, increased a lot the fire size and the frequency of fires, and this is for Valencia area in eastern Spain. But if you look at, for example, in California, because this is a very general process, climatic change occurring everywhere, you get if you look at the old fires, they were more or less small, but all the big fires, the 20 largest fires, for example, in California, they all occur since 2000. Since 2000, since the year 2000. So this is happening everywhere in many places. No? So what are the consequences of having these more frequent fires and more larger fires and so on? Well, one of the consequences is that these pines, that for example, this Pinus nigra, that they were living in areas with these surface fires, which these fires were frequent, and as you can see, they burn in the understory, and they have this thick bark and so on. They were adapted to fires, but these to surface fires. And the proof that they are adapted to surface fires is that if you cut them, you see the fire scars, the years that they were burned. And
And they were burned very frequently. Each horizontal line is a tree. They were burned very frequently until the recent years that there is no fire scars in the trees. But that is not a problem because the tree is growing very, very well and very quick. No? But what is happening is that in the historic times we had this high frequency of fires, which means that it's low fuel in the understory, and then you have these low intensity fires. When we have this strong fire suppression and we have low grazing and all these things, you really reduce the fire frequency. It's very efficient. You can reduce the fire frequency. But then you have a high fuel accumulation in the vegetation is accumulated in the understory, and then when the fire comes, because we are in the scenario of climatic change and human emissions and so on, when there is a fire, then the fire is much intense. Instead of going in the understory, it's going to the crown. And these species don't have these serotinous cones, and then you have this very, very low, almost local extinction of these species. No? Because you change the fire regime. By excluding the fires and excluding grazing, you exclude these low intensity fires, and you have less frequent but high intensity fires. The other consequence is in these trees that have these serotinous cones, that they regenerate very well after fire, even after intense fire. You can have these intense fires, but because they have the serotinous cones, they regenerate very well. But if the frequency increases a lot, then there is not enough time for the pine to grow and produce the cones. So they can survive high intensity fires if they had time to produce cones. But if the frequency, this pine, in this case, the pine philippensis, produce cones the first cones that are produced are more or less at the 15-20 years. So if the fire frequency or the fire interval, the time between fires is less than 20 years, it's something like 10 or 15 years, then there is no time to have this seed bank in the canopy. And then, again, you have this local extinction of these trees. And this happens a lot, for example, in Spain. And the other consequence is that some places, some ecosystems, they don't have all these adaptations that we talk about because they live in places that typically they don't burn. But now, because of climatic change, for example, the fires arrive to this top of the mountains where these plants, these trees don't respond, don't have serotinous cones, and then they die and they don't regenerate. So that's another consequence of this increasing fire activity in places where typically they didn't burn. So, what can we do for that, to solve all these problems? Well, the good thing is that climatic change makes a very important factor, but it's not the only factor. These are also field continuity emissions that we could manage this. The bad thing, the bad news, is that climatic changes keep increasing, and because it keeps increasing, the relative importance of these factors are more important every time. No? So even we can manage emissions and fuel, climatic change is still important and will be very important in the future. So what we can do is not easy, and I'm not going to solve all these problems because it's a big problem, but I'm going to give some ideas, and if somebody wants more information, I can address somebody from Spain that can give you more ideas. But first, it needs to have some clear ideas. For example, it's impossible to eliminate all the fires. No? Eliminating fires is impossible. Many countries have tried. Countries with very, very rich countries, like the United States, Australia, Canada, and so on, they've been investing a lot of money in trying to eliminate the fires, and it's not possible. So that's not the objective, because if you have this objective of eliminating fires, you will get frustrated because it's not possible. That's all. It's very simple. It's a very old-fashioned approach. It hasn't worked in any country. And also eliminating all fires, in fact, it could have long-term negative consequences, because you can build up more fuel, and then with climatic change and sparks and so on, you will have even higher intensity fires. So you have to be careful with trying to eliminate all fires, because sometimes at long term we have negative consequences. So we need to accept that there will be some fires, some certain fire regimes, and what we need to do is that these fires that will occur, that for sure they will occur, they are sustainable from the ecological point of view and from the social point of view. So remember that some of the small, low-intensity fires may prevent high-intensity fires. So not all these fires are negative. So we have to take into account this. So how we can generate these sustainable fire regimes? And that's the key question. The key question for management is not how to eliminate fires, but how to generate these fire regimes that are compatible with biodiversity and with humans. There are few tools. None of the tools, any of the tools that I'm going to show you, save us from big fires, from high-intensity fires. None of them. No? But if you use all of them, or a combination of all of them, in some places they may work in some way. Firefighting is a tool. It's an important tool. It's good to have a good firefighting team, but it's not a solution. If you put all the resources in firefighting, then you're not going to solve the problem. You have to invest in fire prevention, field management, and other things, and not only in firefighting. It's a tool, but it's not a solution. One thing that is important is that, well, to be sure that our fires are sustainable for the humans. So in places around human centers, one important thing is to do field management. It's very difficult to manage the climate, but it's much easier to manage the fuel. So we have to enhance ecosystems with low flammability species. We have to enhance species with sprouting species, because they regenerate very quick, very fast. So even if they burn, but the regeneration is quick. We have to try to, in these areas where close to human centers, we have to generate these landscape mosaics, mosaics with forest and agriculture intermixed, or generate field discontinuities like field breaks and things like that. All these need helps. As I said, any of these will solve the problem, but all of them add to help these problems. Prescribed fires, prescribed grazing, rewilding, all these tools are useful to reduce the fuel and to reduce the intensity of the fires. And also very important to promote rural economies, to consume local products like cheese, milk, or whatever from local entities, because they are the ones that are preserving or reducing the fuel and generating these mosaics. So that's all things. So this relation with the rural economies is very important, because it's the people that is in the landscape, and they can generate easily these landscape mosaics. Then we have also to work with emissions, and sometimes, for example, when there is a heat waves, for example, now in Spain, when there is a heat waves, many of the rural areas, or many of the pathways in the mountains and so are forbidden to walk and to go there, because if there is a spark, when there is a heat wave, then it's very easy to get a fire. So you have to limit human activities in the wild and urban interface, and especially during the heat waves. remember the small low-intensity fires, fires that occur, for example, in spring, they are not so bad, and they prevent having high-intensity fires in summer. And one thing that we need to be sure that the fires are compatible with human societies, we need to reduce the urban planning, the wildlife-urban interface, and I will explain this later in another slide. And also we have to houses that are in areas, in forest areas, but we need to promote this fire-safe gardening and evacuation tools and building with fire-resistant materials and all these things that are important. No? Because we know that fires will occur, no? You have to be prepared. No? So you cannot rely on that the government is going to stop the fires. There will be fires in many places, in many Mediterranean ecosystems, so you have to be prepared, that your houses and everything have to be prepared. And of course, there is more general things that you can do. It's like, of course, try to conserve water cycles in the watersheds. And for example, preserving wetlands and things like that are ways to preserve the water cycle and thus to preserve the climate. And of course, trying to fight against global warming and try to reduce fossil fuels, not only for fires, but for many other things. But also important here. So, field breaks is not a solution. Sometimes it helps, no? If you clean around your house, and then when there is a fire, you are protected. And there are examples on how thinning and prescribed fire saved some of the fires compared with areas that were not thinned, or things like that. No? It also was cleaned and so on, so the fire stopped in the place where the vegetation was managed. So there are some successful stories, and also there are some failures. No? There are some places that you make a field break, and then there is a point of erosion, or there are field breaks that the fire can cross very easily. Sometimes the fire can cross highways, because especially when these wind-driven fires, when the wind is very strong. So none of these, as I said before, is a solution by its own, but each one may contribute to generate these fires that are not so dangerous and are more or less sustainable. And I want to emphasize a bit the importance of reducing this wildlife-urban interface. So these houses that are growing every time we have more and more houses in the middle of the forest. Not that people like to live in the forest, but this is getting with the climatic change and with all these changes, is getting even more problematic. First, because you are putting people in danger. If you allow people living here, you are putting people in danger. That's for sure. Because we know that many of these ecosystems will burn. But of course, these areas also destroy biodiversity. They increase the number of invasive species. They are source of emissions because there is activity, there is cigarettes, there is machines and cars, motorbikes, and all these things that generate sparks. So this is a source of emission. It also increases flammability because if you have roads, instead of a forest, you have herbaceous vegetation next to the forest and next to the road, and this is much more easy. If there is a lining, it's much easier that the fire will start next to the road than in the middle of the forest. And also, it changed it converts any fire, that even fires that may be sustainable, so maybe all these plants in this area, maybe they regenerate very well after fire, so maybe from the ecological point of view, a fire here is not a problem, because it regenerates very well. This happens in many ecosystems. But building houses here converts this fire in a catastrophic, something that from an ecological point of view is not a problem. I think it becomes catastrophic. So I think this needs to be in the past when without climatic change probably this was not a problem, but now that the fires are becoming much more frequent, living like that is dangerous. And I'm going to explain you an example, and this is from California, but I choose this example because it's very informative and but it happens here in Spain and so on, but this is very well documented. So in 1964, in Northern California, there was this fire in red, and this fire is and it was a big fire. You know? 21,000 hectares, which is quite big. And this fire, it was in 1964. Nobody died in that fire, and there were a few houses, about 100 houses that were lost in this area. In 2017, the black area was burned again, in the same area. 20 people died, and more than 5,000 houses were destroyed. So, and this fire was 14 or 15,000 hectares, so it's smaller than this. Here, it's smaller than this one. So, the recent fire, which was smaller, but was much more catastrophic. Lots of people died. So some people say, well, that's climatic change, because you know, the high intensity and so on. Whatever. Well, if you look at in 1964, you have this Santa Rosa town here, city, and you have this fire. The fire was here. But after the fire, this area burned was colonized by a lot of houses. And this colonization of houses, and then it burns again, and then of course it burns again, and there were houses, so a lot of people died. So between the two fires, there were 53 years between the fires. These 53 years, for the vegetation, to have another fire for this Mediterranean vegetation, which is a chaparral type, it's a very Mediterranean vegetation, a fire interval of 53 years wasn't a problem. The problem is that you are building here, and then, of course, it becomes a catastrophic fire. So this is a very illustrative of the importance of urban planning when dealing with fire management. So here, for example, is an example of in Spain a very big fire, 21,000 hectares, that burned everything. In the middle there is a town, but there is an old town, and this kind of old town that all houses are together, aggregated, so nobody was killed and nobody died, and very few houses were affected, and it was a very high intensity and very big fire. In the middle there is this town. In the way we are building now houses, if there is a fire, there will be a catastrophe. So that's two different models of living that have different consequences, which is independent of climatic change. But climatic change makes this more susceptible, more easy to burn. So to finish my talk, fire is a very old phenomenon in the history of life. Many plants have traits and strategies to persist recurrent fires. Fires act as a selective pressure, and different fire regimes can select for different traits. Fire explains a proportion of the variability in biodiversity in our planet, not only in Mediterranean ecosystems. But the problem is when we have these abrupt changes in fire regime, which may generate these losses of biodiversity, when we change these fire regimes. Human activities, changes in climate, changes in emission, changes in land use, are increasing this fire activity, and then they are threatening this, not only species, but also society. So management, the objective is not to remove fires from the system. It's too dangerous, and in fact it's impossible, but to generate these sustainable fire regimes from the ecological and social point of view. There is no single solution. We need to apply multiple approaches, including reduction of the exposure to fires. No, that's what I'm saying. No, if you go to live in an area that burns frequently, even if it burns every 50 years, in the natural conditions burns every 50 years. Well, if you live there 20 years, maybe you don't get burned. But if your son maybe or your child, whatever, if they keep living there, they will get a fire. No? So we have to reduce this exposure to fire, and of course we have to keep preserving climate and water cycle and reduce CO2 emissions and so on, all these things that you already know. So, just to let you know that this is a book that explains more or less some of these things that I explained, mainly about all these traits for plants in methane ecosystems. Well, I cannot see it. And that's all. Thank you. So I'm happy to answer questions, and if you have questions in Turkish, okay, to translate.
How can we ensure that we are not overgrazing an ecosystem by?
How can you ensure it?
How can we ensure that we are not overgrazing an ecosystem?
Overgrazing?
Yeah.
Well, that's a good question, and that's complex. So, if you overgraze a lot, of course you reduce the fuel and you have less fires. And you remove the grazing, then you have more biomass, you have more fires. No? And to reach the intermediate position, that is what I'm trying to say with mosaics and so on, is the key. No? And each ecosystem can support more or less grazing. But in general, to overgraze in some way that is very bad for the ecosystem, it's not easy. You need to if you have a shepherd and with a lot of concentration, you may have this overgrazing. No? But I think it's possible to control this.
For example, there is a pine forest north of Ankara that I visit like 2-3 times a year. There was a intense fire, and it is Pinus nigra forest, and they survived,
Yeah.
But however, there is an overgrazing problem in the area, and I can't see any young pine seedlings. It's impossible to see any young pine seedlings in the area.
That's very important. Pinus nigra lives a lot of years. It's a very the longevity of the pine nigra is quite high. No? So you don't need to have pine seedlings every year. And even if you have pine seedlings every 50 years, that's it. Yeah, well, if there is a lot of overgrazing, then it's a problem. We have this problem as well in Spain, in some places, like in the, I don't know if you know the ESA system, that we have very big oaks, but no regeneration because of the overgrazing. So what we are doing in some places is try to protect some areas, some stripes, some areas without grazing. So you have some regeneration, and then you remove the fences. You put some fences, you allow them in some places to regenerate, and then you remove the fences, or you put in other places. No? And so you can keep changing this, so you have some regeneration. You can manage this.
But how many years, I think?
Well, this depends on the system. It depends on the system. When you see that in that case, the pines, in our case, what was saying, the oaks, when they are big enough that the animals don't eat them, then you can remove the fences and put it in another place. When they are safe, from the herbivore.
The area that I mentioned, around the area that I mentioned, is a natural Pinus nigra forest, but forestry departments try to plant cedar trees. Is it wrong? How can it be wrong?
Well, I don't know the area, but if the cedrus is not natural there,
native. It's not native in the area.
It's not native. Well, if not native, for me, a priori, you shouldn't do it. At least there is a reason for that. No? For example, if it is a forestry plantation for wood, it's another question. It's like, you know, if you plant potatoes or tomatoes, it's not native. But if you are using because you want production, then that's fine. No? So for the forestry, it's a bit similar. No? In some places, because we are all using wood, in some places you need to plant trees for wood production, knowing that it's the problem with fire and so on. But in that place, specifically that place,
Visual.
yeah, if it's for that, then probably it's not necessary. I will try to. I will always suggest if it's only for, if it's not for a product. Yeah, if it's not for production, then I would suggest always trying to plant native trees, of course.
Thank you for
Thanks.
Hi Juli, thank you so much for your presentation. I have a question about this rural abandonment and wildlife urban interfaces. When you mentioned that rural abandonment forms a continuous fuel for fires become more severe, it also creates more continuous habitats, preventing for habitat fragmentation.
Yeah.
I was wondering how should we set the balance of these rural areas to prevent habitat fragmentation, but also prevent the continuous fuel field.
Mm-hmm. Yeah, that's a good question. Of course, when you try to design these mosaics, you can take into account these corridors and all these things. So I think it's possible. Fragmentation is especially important when you have all these very large agricultural areas that are very intense, which is not what we're talking here. No, we are talking here that you have a landscape and you put patches of agriculture to generate these continuities so the fires are not so intense and so on. No? But the fragmentation is especially important when there's all these big areas that intense agriculture, big machinery, and so on. No? And that's where it's another problem. No? So in these landscapes, of course, they don't burn. But in the landscape that they burn, when I say that in chorus mosaics, this area is I'm referring to small things and for small vegetation patches and so on, that small agricultural patches and so on to generate these mosaics. That they should not create this fragmentation that is a problem for the animals and so on. In fact, it's what happens in the past. And of course, you have to balance. No? There is no a clear solution. No? It's like grazing, and you cannot go to the extreme and generate big agricultural areas and big field breaks and so on, because then it's a problem. No? But some may help in generating these fires that are not so dangerous and easy to stop and so on.
Also, the houses you visualize that which have fire corridors around them, it also requires so much area. It's not a big area for 50 houses, but when it comes to 1,000 houses, and if all of them have this large garden around it, so it creates a problem. I guess. I'm just assuming that.
Yeah, well, but this is a planning problem. If you decided that here there are going to be 1,000 houses, if the government or the municipality of decided that you're going to be 1,000 houses here, you know that if you put 1,000 here and 1,000 here, you have to remove all the vegetation and have consequences for biodiversity and so on. If you don't want that, don't build 1,000 houses there. But if you put houses plus trees, then when a fire comes, you will have a problem because you can kill people. So you have to balance. And so it's a political issue. It's not an ecological issue. It's a political and management planning and economical, of course.
Thank you so much.
So, firstly, thank you for your presentation. It was really great for me. So you mentioned the relationship between the understory and the fire regime, and so following the big fires. So here in Turkey, so some people, so let's say, so some tourists believe that if we cut the shrublands and we clean up the shrublands, then that will stop the fire in the future. And so, so my question is: do we really need that, or what do you think about it?
So let me sure that I understood the question. The question is that if you cut the understory,
yes,
then you prevent the fire.
Yes, yes.
Well, in part may be true, but but it has a cost of biodiversity. So, so if you cut all the vegetation, you don't have fire. But you cut all the vegetation. So you have to balance. So you have to use ways to reduce the fuel that are not so hard for biodiversity. That's why I say that you have to take into account both biodiversity and social issues. And there are ways. You can do some cleaning, of course, if it is close to houses, you have to do it, because to reduce the danger to the people. But in places that are outside of the houses, then you only have to reduce the fuel if it's needed. And if it burns, it's going to be a problem or not. And what ways to reduce the fuel? And the story fuel, you can cut them, but sometimes it's more, it's less aggressive, less intense. If you put animals for grazing, herbivores, or even if you do a prescribed fire. Some people don't realize, but sometimes if you do a prescribed fire, it's less dangerous or less dangerous for the vegetation than if you cut them manually, because it means going through with machines and so on and cutting everything and so on. But if you burn in a moment that is not very dry, so the fire will be of low intensity, you reduce the fuel, and it's not that drastic and that heavy for the vegetation. So there are ways to do it, but of course we need to know if it's needed or not in a given place.
And my second question will be, how can you compare the low density fire with the high density fire? There are some so classification between them. What do you use for it?
Well, yeah, I simplified very much in my talk, talking about low intensity. When I was talking here low intensity, I was talking these surface fires that they don't burn the canopy, and high intensity fires, the fires that burns the canopy. Of course, this is a dichotomous classification, a very simple classification. Of course, there is a gradient of intensities. And even in surface fires, there are higher and lower intensity fires, and even in the canopy fires, crown fires, fires that burn all the tree, they're also more intense and less intense. But the key point is whether they burn the canopy or they don't. And there are some plants that are more adapted to one type of fire, and some plants are adapted to the other type. For example, many of the respiratory species, they can respire very well even after high intensity fire, crown high intensity fire. Well, these plants that have this thick part, they only survive in surface fire, low intensity fire.
So this year, so when we were working in Mars, so together with the team, so we used the parameter, so the classification of the normalized burn ratio, and so
from NDVI.
Yes. So do you use another remote sensing so something with your study? Yeah.
That's a good approach at landscape. So for big areas,
So for big areas, this is good. But when you go to a specific places and you relate with the plants that are there, we use this, whether the plant burn, and also we use whether the branches are thick or thin after fire. If they are very thin, this means that there's been low consumption, so there is a low intensity fire. And if it's very thick, it means that there are a lot of consumption and high intensity fire. But at the end, it depends on the question that you have. Depends on the question you have. One system of measure fire intensity or the other, in fact, is fire severity. Fire severity or the other is better. One depending on your question. But at regional scale or landscape scale, LTBI is a simple and nice way to do it for big areas. But if you want to work at plant level, at the species level, what happens here and what happens there, then these are other ways to be more specific.
So thank you.
Hello, Doctor. How are you? This is more of a policy-based question rather than a scientific question. I was a delegate at the pre-COP26 Youth for Climate Summit. I don't know if you've heard of it. And throughout that, I've been in the loop of all the policy decisions, and that happened at COP as well. And during COP26, there was a sort of a treaty on forests and land use, a declaration. And there was around $12 billion that were allocated for the conservation of forests and all the works. So where do you think this is enough, first of all? And where do you think this money should be allocated mostly? Do you think it should go to prevention or to technologies in forest conservation? And what do you think in general, if you have been informed about what happened during COP26, what do you think of the process in general?
So, if I understand correctly, the question is, where I will focus money or whatever, where I will focus the conservation, for conservation?
Well, just in sustainable forestry in general.
Yeah, that's a difficult question. For sustainable forestry in general, well, for sure, one key point for sustainable forestry in general, to say, is to prevent burning these forestries, these forests. And so it's much more important preventing than firefighting, for example. That's much more important. So I think if you have some areas that you want to conserve and preserve, I think you have to do this kind of thing that I've been explaining. This kind of mosaics are around the area that you want to preserve. So in case the fire is coming, the fire is going to slow down and it will be easy to stop. So I think working on prevention and fuel management and things like that in areas that you want to reduce the fire activity is very important.
But can we say, for example, that with the intensifying climate effects, that prevention might not be sufficient anymore? Because the fires are becoming more intense, more frequent.
Yeah, what happens is that fire is going to become more frequent and more intense and so on. So this means that if you want an area to save from the fire, then you have to probably to do much more intense management. And also you have to accept that some areas are going to burn. And this is something that the people have difficulty to understand now. Because some areas, if they burn, some areas, if there is no people living there, maybe it's not that dangerous. It's not that a problem. Some areas. No? So some of our forests, as I tried to explain, are more or less adapted to some fires. No? So if there is no people living there, and because fires are going to be more frequent, so you have to try not to have the people, put the people in danger. So they are going to burn. So you can do this fuel management, mosaics and so on, to reduce this frequent, the size of the fires, to facilitate the firefighters, to stop the fires and so on. But you are going to have fires anyway, for sure. So you have, and with the climate change, this is going to happen. No? So we have to get used to this, no? And to understand that some places are going to burn, some places we should not live there because it's too dangerous. Or if you live there, you have to know that sooner or later will burn. So it's at your own risk and things like that. No? And some places, if you want to preserve an area, a fire going through one area, you have to do a very strong fuel management. I don't think there is much more solutions.
So despite all of whatever money we put into it, we have to accept that there are going to be areas that are going to burn because of the climate crisis.
Yeah. If you have flammable ecosystems like you have in the south of Turkey, these areas are very flammable. So if there is in the middle of the summer, which is very dry, if there is a spark or a lightning, you are going to have a, if there is vegetation, sooner or later you will have a fire. You have to accept that. It's been fires for many thousands of years, and they will be, if there is still vegetation, so there is still conservation of nature, then there will be. The question is whether this is dangerous or not. It can be dangerous for the people if the people is living there. So we have to organize people to live in places that is not that dangerous. And the second question is whether it's dangerous for the ecosystem, for the vegetation, for the plants and animals. And in some places, if the frequency is very high, it may be a problematic for nature, for animals and plants. But if the frequency is not very high, even if the fires are intense, maybe it's not that problem. So you have to balance. So we are in an area that fires are going to occur. So we have to have a high acceptance level. We have to accept some level of fires and some level of destruction, even if you want. But of course, a level of conservation and so on. Because if we aim for stopping all fires, then we will get frustrated because it's not possible. No? So we have to be careful that accept fires and try to regulate them in a way that are not very dangerous. No? Like a rainfall. No? Sometimes you have a strong rainfall, and you have to be careful that the floods don't cover the houses and all these things. No? But with the fires, well, you will have fires, you will have rain, but you have to have these fires that you want these fires not to destroy houses and not to destroy nature. No? And this is what you have to work with. And as I say, there is no single solution. You have to work in different directions and try different things and to see how your system, because each ecosystem is very different, each landscape is different, different winds, different humidity, etc. The fires behave very different. And in your system to see what is better is if you do a prescribed fire there, do nothing, put some ships there, all these things. And you have to keep trying many things, because nobody has the solution.
Thank you very much.
Thank you for your speech, first of all. You mentioned that invasive species are contributing an increase in fuel continuity. I was wondering if we can think of fires as a control mechanism against invasive species or maybe diseases in Mediterranean ecosystems.
Yeah, that's a good question as well. Well, against invasive species, it depends. It depends. In some cases, it may work. but in some places it doesn't work. For example, I will give you an example. No? In California, for example, most of the invasive species, many invasive species, take the opportunity after fire to colonize new environments. No? So fires has facilitated the entrance of some of these new alien species. No? But also, for example, in Portugal as well. No? Portugal, there is acacias, species from Africa and from Australia, that they are invading, and because these species have these seeds that are stimulated by the fire, so the fire stimulates even more these species. No? So in many of these cases, fire is not a tool for reducing the invasive species, but in some cases could work. No? There are some examples. For example, I remember in the Pyrenees, in the north of Spain, there is an invasive plant, and the people, when they were managing shrublands to reduce the shrublands for having grazing laws, no, for pastures for grazing, they cut the shrublands to have more herbs for the animals, and then you have these invasive species increasing. No? Because when you cut the shrublands, you have a gap, and then these invasive species was increasing. And they realized that instead of cutting the shrubland to burn, then you kill the seeds of these invasive species, and this species doesn't increase. No? So in that specific case, it works. No? Fire helps to prevent the increase of the invasive species. But there are only special cases. In many other cases, it's the opposite. No? So you have to be careful, because in your system to see which species you want to prevent, and whether it's fire stimulated or whether it's not. No? So this is one thing. And the other thing that you mentioned as well is the reduction of diseases. No? And this is interesting, because it's been used for reducing diseases. For example, many primitive humans, or for example, or tribes in Africa or in Australia, aborigines in Australia, and so on, they tend to, even some farmers, many farmers, they burn the area to reduce the number of diseases, no? and to have a more clean and safe environment. No? So this is humans have done this for many years, no? To burn areas that were settling, so were going to live, and then to have this more clean with environment. And in fact, with that, if you look at lizards, we've been studying lizards and comparing lizards that live in an area after fire and lizards that live in a shrubland that hasn't burned. No? And the lizards that live in an area that hasn't burned have more parasites than the lizards that live in an area that has recently burned. Because many of these parasites live in the vegetation and then parasite these lizards. So if you remove the vegetation, and you reduce the load of parasites, and these lizards benefit for a few years of a more clean environment. So these things happen sometimes. But many farmers as well use burn to clean for diseases for the animals, for sheep and cows and things like that. Thank you. More questions?
You defined the catastrophic fires as mostly the ones that affected human life, economy. But what do you think about about such mega fires, negative effects on the ecology or ecosystems? Are there any cases worldwide? Can we describe megafire as a destructive to ecosystem stability, continuity, and
well, yeah. Well, in fact, there is no definition of megafires at the moment. There is no definition at the moment. People use megafires. Usually, depends. Some people use megafires as fires that are bigger than 10,000 hectares. Some people use megafires when there is people killed or when the firefighters cannot stop it. So there is many definitions, so there is no simple definition. The question is whether some of these fires, megafires, can have negative consequences for biodiversity. And of course, yeah, they can. No? Because we know that some ecosystems are not adapted to fire. Some ecosystems, they, for example, when we go to the mountains, at least in Spain and probably here, no, we go to the mountains, fires in the history has always been very small. Frequent, more or less frequent, but very small, because it's cold weather and wet and so on. And with the climatic change, this area is drier, and then you can have large fires. And these plants don't sprout, they are not serotinous and so on, and then they have to colonize. But when the fires were small, the colonization from the outside is very quick. When the fires are very big, the colonizing for the plants, large fires, is much slower, and it may take many years. So yes, there are some biodiversity problems, no, with increasing fire. And this is one example. And the other example is when you have these very frequent fires, as the several fires we talk about. You have frequent fires, even if they are small, but they are so frequent that the plants or the plants, they don't have time to reproduce. So then you have another biodiversity problem. So yeah, there are some fire regimes that can be catastrophic for humans. There are some fire regimes that can be negative for biodiversity. But what is important is that there are also fire regimes that are not negative. And these are the ones that we have to think and to drive the system to to those regimes that are not that negative, or are very little negative, or not negative. And that's a difficult question. But what is important is that this is a very different target, very different objective, than trying to stop all the fire, which is, as I said, it's very difficult and almost impossible.
We are also open some Turkish questions. Türkçe sorulabilir arkadaşlar, isteyen varsa. If not, thank you very much for your nice presentation. And here, share your experiences.
Thank you.
And thank you for your participation here. Listen all these hot topics about fire. That's